Hello students. Today we will discuss a new article 6.4.2 linear differential equation. Now in HSC board in this year this article is reduced in our syllabus. That means the examples or the question on this article does not ask in HSC board examination. But the article is important to solve some application of differential equation as well as the exam JEE. Therefore, I explain what is meant by linear differential equation and how to solve the linear differential equation. Now, the first we see what is meant by linear differential equation. A differential equation is in this form: dy by dx plus py is equal to q, where p and q are function of x. Then we say that this equation is called as the linear differential equation. For example, dy by dx plus p is the function of x. Suppose we take p is equal to 1 by x into y is equal to q is also function of x. We take e raised to x. That means dy by dx, here p is the function of x into y is equal to q is the function of x. Such a type of equation is called as the linear differential equation. Also, the another form of this linear differential equation is dx by dy plus px is equal to q, where p and q are the function of y. That means we take example dx by dy plus we take same example 1 divided by y into x is equal to e raised to y. That means this p and q are the function of y, this p and q are the function of x. Now such a type of differential equations are called as the linear differential equation. Now we see how to solve the linear differential equation. Now the linear differential equation, the form is dy by dx plus py is equal to q. Right, equation 1. Now consider d dx of y into e raised to integration p dx. We take derivative of these two product of function y into e raised to integration p dx is equal to y derivative of e raised to integration p dx, e raised to integration p dx. The derivative of e raised to x is e raised to x, but again in place of x here integration of p dx, then d dx of integration of p dx plus e raised to integration p dx and derivative of y is dy by dx is equal to, in each term e raised to x is common, e raised to integration p dx is common, bracket first y into integration derivative of integration of p, that is this integration and derivative cancel, only p plus here e raised to take common e raised to p dx, then remaining dy by dx is equal to e raised to integration p dx. Now from equation 1 the value of dy by dx plus y into py is equal to q. Therefore d dx of y into e raised to integration p dx is equal to e raised to integration p dx into q. Now by using definition of integration or taking integration on both sides, on integrating both sides, on integrating both side, the left hand side derivative cancel, that is y into e raised to integration p dx is equal to integration of e raised to integration p dx into q plus c. Here e raised to integration p dx is called integrating factor if shortly. That means solution of this equation is y into if integrating factor, that is e raised to integration p dx is equal to integration of if into q dx plus constant c, which is the answer. And if we consider the equation in terms of x, then x into if is equal to integration of if into q dy plus c. Now which is the solution of dx by dy plus px is equal to q. Here p and q are the function of y. Here important thing is to find the integrating factor. if is equal to e raised to integration p dx first, and second if is equal to integration p dy. In JEE exam, the question is asked, what is the integrating factor of the given linear differential equation? We apply this formula first to find integrating factor. Now we solve one example, how to solve the linear differential equation. We take one example, that is dy by dx plus y is equal to e raised to minus x. Now answer, comparing with dy by dx plus py is equal to q. Here p is equal to 1, coefficient of y is 1, q is equal to e raised to minus x. First we find integrating factor. if is equal to e raised to integration p dx is equal to e raised to integration of p is 1 dx is equal to e raised to integration of 1 is x, which is called as the integrating factor. And write the solution, y into if is equal to integration of q into if dx plus constant c. Y into if is e raised to x is equal to integration of q is equal to e raised to minus x into if is e raised to x dx plus c. Y into integration of e raised to y into integrate factor e raised to x is equal to, here the base is same, its sum e raised to minus x plus x dx plus c is equal to integration of e raised to 0 dx plus c. E raised to 0 is 1 dx plus c. Y into e raised to x is equal to integration of 1 is x plus c, that is y into e raised to minus x plus x is equal to x plus c, or only we write y is equal to e raised to minus x in bracket x plus c is the final answer. Now in this way we solve the linear differential equation. First we find the integrating factor. This integrating factor is most important. We take second example, only find the integrating factor. The example is only we find integrating factor. The question is x into sin x dy by dx plus x into cos x plus sin x into y is equal to sin x. Now this equation not in the form of linear differential equation, but we convert this equation in linear form dividing both sides by x into sin x, then we get dy by dx plus x cos x plus sin x divided by x into sin x. Into y is equal to sin x divided by x into sin x. Then dy by dx plus its quotient is cot x plus sin cancel 1 by x into y is equal to sin x into sin cancel 1, that is x, sin cancel. That means comparing this equation dy by dx plus py is equal to q. Here p is equal to cot x plus 1 by x and q is equal to x. Now we cannot find its solution, only we find the integrating factor. The integrating factor if is equal to e raised to integration p dx is equal to integration e raised to integration of p is cot x plus 1 by x dx is equal to e raised to integration of cot x dx plus integration of 1 by x dx. We take the separate integration. Then e raised to integration of cot x is log of cot means cos divided by sin. Derivative of sin in numerator, therefore log of sin x plus integration of 1 by x is also log of x, that is e raised to log of its sum, therefore we take product sin x into 1, sin x into x, e raised to log of sin x into x. By using relation between logarithmic and exponential function, its value is only x into sin of x, that is if, which is called, and its solution is y into if is equal to integration of q into if dx plus c. Substitute value of q and if. We solve this example. The MCQ question is asked what is the integrating factor of the given differential equation. Then we reduce this equation in linear form and only find the if. In this way we solve the linear differential equation as well as we find the integrating factor. This integrating factor is most important factor to simplify the solution or solve easily to the differential equation. Okay, next period we study the application of differential equation in physics, chemistry, mathematics as well as economics as well as bacteria in culture, that is biology. which is the part of our HSC board syllabus. Now this part is not asked in HSC exam, but useful to solve some linear differential equation in JE exam. Okay, thank you.